Good morning and welcome to the final day of Technology, AI and Cyber Live. It's been a great show so far, as I'm sure you'll agree. And today it's only going to get better as we adopt a more regional focus, starting with our friends in Asia Pacific. So good morning to you all. Now, kicking us off in style is Jackie Teo, Chief Digital Officer at HGC Global Communications. Jackie is responsible for technology and digital capabilities for customers and internal staff. This includes strategy, roadmap, architecture, delivery, support services, as well as P&L accountabilities. Over the last 25 years, Jackie has led significant technology transformations across large and complex organizations. Jackie's held several C-level positions globally in the telecommunications, media, and entertainment industries. She's been a key player in creating industry game changes and shifting paradigms for her customers. Technological progress, ubiquitous access to technology, and technology to improve our lives are just some of her passions. And I'm sure she can tell us much more about that in her session. So welcome, Jackie.
Thank you so much, Scott, and thanks for having me here today. What a great series it's been, and what a great set of speakers. I'm just super excited because today I'm going to talk about something that's probably close to a lot of people's hearts, and that's about 4 skills for data professionals that I think are going to be very essential soon, if not already, in our industry.
Okay, Jackie. So over to you then.
Perfect. So, hi, everybody. Good morning, good afternoon, and good evening. Hope you're all having a fantastic week here of this series and enjoying all the sharing and all the information you're getting. So, what I'm going to talk about today is, some of these key skills as we look at AI, data and security, really, moving into that next evolution and really how to make yourself stand out from the crowd in what's becoming a very high demand space. So I think, one of the most important things, no matter what your role and title is in this space, is of course the basics of what data is and to know how to differentiate yourself and how to differentiate what good data is. And I think where you start then is, of course, to understand the trends in data, AI, and security. So 2 things we're going to cover today. What are these data trends? What are these technology trends in data? And then 4 new skills for your arsenal, right, as you go forward. How do data professionals determine what is useful and usable and trustworthy data? And how do you know your model predictions are going to be trustworthy and they're going to generate superior outcomes? So why would somebody use you as a data scientist over someone else that is an equally good data scientist? And I think that's what's driving a lot of thinking on our minds at the moment. So you got to ask yourself, are you creating, using, enriching, monitoring your data and your models, and therefore what do you do to stand out in this crowd, in this data-driven digital world? And it's just going to get to a point where a lot more data is going to be generated in a lot more spaces. All right, So here's my personal view. Here's the 3 data technology trends that I think are going to become increasingly mainstream if they're not already at the moment. The first one is the rise of deepfakes. This should not be a surprise to a lot of us, but I think they're just going to be more, you're going to see a lot more of them in the near future. The second trick that I think is going to affect us is poisoned data. And this is going to be really quite interesting. I think this is a new frontier for security integrity attacks. And there's, it's growing at the moment. There's a few good examples coming out in industry, but I think this is one of those really key spaces to watch for us. The third area is the use of synthetic data, and that is also growing. And it's a little bit of an anomaly. As much as we say, there's too much data everywhere, there's, zettabytes, petabytes, et cetera, that's being generated per day on the internet. The use of synthetic data cannot be underestimated. And the move towards hybrid data sets for training is just going to increase as well. So with those 3 data trends in mind, let's talk about what it means for us in this space, in the areas of AI, data, and security. So the first one, let's talk about deep fakes. I don't think this should be any surprise to a lot of us. You think about just not so far ago, not so long ago, in 2019, if you remember, Salvador Dali came back to life at the Dali Museum in Florida. So they actually projected Salvador Dali, and he actually did selfies with everybody. So he adopted modern behaviors. And so this AI robot that they actually put out was actually really quite interesting. You also have things like David Beckham, fighting to end malaria, and he, speaking 9 languages very fluently to do that. I think most people are familiar with the Tom Cruise deepfake. And more recently in Asia, we have something called Xiao Eyes. And this is really quite a phenomenon. This is the Microsoft AI chatbot that mends broken hearts. And, it's like people actually think it's very real. And at the moment, there's more than 600 million users of this I'm going to call it an application, and it's people actually consider it really quite real, and it's for males and females as well. So there's a lot of good things coming out of using deepfakes, but we also know that deepfakes can be used and are used today to defame, impersonate, and blackmail targets. So if technology can impersonate someone's image, their voice, how they write, etc., then I think there's a potential to incorrectly authenticate customers, bypass biometric systems such as facial recognition, optical scanners, voice authentication, etc. And so, as professionals in this space, we've got to think about what does that mean when we use data for things like KYC, identity management, 360-degree views, etc., etc. I'm not going to cover the technology of GANs here, but I think we can agree that deepfake technology is advancing rapidly, and it's getting harder and harder to spot a fake in the marketplace. So as a data professional attempting to use any data, you need to start thinking about how to incorporate a very key area called data provenance in what you do with your data. And this is to establish authenticity and trust, as well as to contemplate things like legal compliance and regulatory implications of using such data, especially when the data returns a less than 100% trust score for you. Now, on the other hand, I don't think deepfakes are all that bad. I think the technology is fascinating and also gives us a plethora of creative outlets and applications to generate new opportunities. And this is only limited by the imagination of the AI modeler. So as an AI modeler, I'm going to say as an algorithm modeler, you've now got a whole new creative field that you can actually step into. And I think that's quite fascinating. So then think about how, you can fit into things like digital marketing, service industries, welfare and consulting, patient rehabilitation, paramedical, et cetera, et cetera. And I think those are really quite exciting areas. So then let's talk about data poisoning. All right. Data poisoning, I don't think is a new area too. I think it's probably something that the industry hasn't really figured out how to respond to. And this is quite similar to deep fakes, but I find data poisoning a little bit more sinister, and that involves tampering with training data sets. So these are the fundamentals of what drive your algorithms. And it is designed so that it is actually hard to detect any perturbations of that data. And this gradual modification of learning outcomes potentially will skew generations of actions, decisions, thoughts, behaviors. So over time, think about it, actors can make good software code seem like malicious code. All right. And they don't have to do very much to it. What they're trying to do now is they're trying to gain access to things like original training sets, the type of model that they're thinking to be poisoned, hyperparameters, the objective function. So actually minimizing or maximizing, I'm going to say, the training errors. So causing the algorithm to actually maximize the training errors, which is really quite interesting. And they don't need a lot of data. They can actually use approximate data. So say, for example, the goal is a backdoor attack, then the attacker only needs to set the test set to contain the backdoor data points, right? And the model is then trained to provide incorrect predictions. And you can actually train AI models to do that. So I think that is really going to be quite a big field, and I think very soon we'll see a lot of companies and technologists actually throw some weight behind trying to deal with that. Now, what it's also going to do in the industry is, I can foresee, a whole group of new type of white hackers, probably a new breed of gray hackers growing up around this. At the moment, you don't have too much movement there, but it actually is quite interesting in that space. So, I think there are four key ways of how people poison data together today. I don't know if there'll be more tomorrow, but certainly there are four ways that we know of today. The first one is really simple, right? The attacker can change the way the algorithm learns, and that's probably the most dangerous because that fundamentally changes how your outputs. The second one is that bad data can be introduced, and that's really quite logical. One way to do it is to manipulate data labels. So you see the growing phenomenon of data labeling. I think Stanford's latest unicorn Snorkel was just valued at $2 billion. That's a data labeling unicorn. Another one, more sophisticated way, is to actually manipulate the input itself. So you can do things like shift classification boundaries, change cluster distances, et cetera. And that really is quite sophisticated. The third way actually is where the attackers actually insert fake data into actual data sets, and they skew the model to weaken the outcome. So over time, what is supposed to be malicious doesn't seem malicious anymore. So this weakened outcome serves as a very easy way for attackers to then attack the victim. The last one is then transfer learning, which a lot of you may be familiar with. It's about poisoning the algorithm and then spreading this poison to the next set of algorithms as the network goes through retraining and retraining. So it loses its original memories of the original outcomes of what it was trying to do, right? And the most interesting thing I think I come across is that there was a bunch of researchers, and what they did was they managed to get the US street sign classifier to learn to recognize stop signs as speed limits instead of stop signs. So over time, you can actually influence and change the actual outcomes. So what does this actually mean for us? I think just as application developers need to incorporate security standards and features into their code base, when you've got DevSecOps. So I think model designers now need to embed cybersecurity thinking when they're building their models. So as AI grows commercially, as edge cloud increases, and more data modelers and engineers distribute their data services, I think you're going to get called upon to support security operations and cybersecurity incidents and probably the crafting of policies more and more. So I think there's a big area to improve in terms of our skills and our understandings beyond just data. The third area of technology trends, I think, is in quite fascinating. It's in synthetic data, and there's a lot of reasons we would use synthetic data. I think data is not available. You've got legal compliance. You just can't get access to the data. You're not allowed to. Things like medical records, for example, got security concerns. And sometimes it might just not be worth the cost to go get access to that data. So a lot of companies do, certainly we do, we create synthetic data for ourselves based on the original training sets. And, I think what good data scientists need to understand, and they need to be balanced, is there is a time and space to use synthetic data, but you need to apply some critical thinking to this. And the most important thing I think you can do as a data scientist is to understand the context in which you're using the synthetic data. So you need to recognize some limitations of real data sets. And then you need to recognize the limitations of using synthetic data with those data sets. So things like, for example, the quality of synthetic data actually depends on the input source data anyway, right? You might have a challenge in user acceptance because you're using synthetic data, and things like the data generation actually can be more costly. There are instances where, it takes time to go generate this data, think of all the scenarios in which you use this data, and actually go and label this data. So I think this is one of those places that really is going to test some of our data skills. So that was a quick whiz through, I think, these technology trends, and I'm sure we could spend the next couple of hours, if not days, just talking about that. And I'm sure there are a lot more that you guys can think of that will impact us as a profession. So let's think about then how to embrace these three trends, right? So what are some skills that you're going to think about? And I think a lot of you can already see some of the obvious ones, right? But you're going to have to embrace these. These things are not going away. Deep fakes, poison data, synthetic data, they're not going to go away. And actually, they're going to become, very, I'm going to say BAU, or very mainstream in how we use and deal with data every day. So I'm going to talk about 4 areas that I think, this is my personal opinion, of what I'm seeing. Certainly when I hire in the market, I'm looking for people that actually have these skills, or have the aptitude for these skills, or have the ability to think about data and layer these views on top of it, right? So 4 areas: DevSec. It used to be DevOps, and it became DevSecOps. Now you've got DevSec, Data Model Ops, and I think this string is just going to keep growing as everything gets more integrated. So really, I'm talking about model ops, right? Which a lot of people will be familiar with. The second area I've already mentioned, it's data provenance. I think in the past, not a lot of focus, especially in governance frameworks, has been given to data provenance, but I think that's going to become really important. The third one, of course, because we're talking AI, data, and security, data security. But in a different way, I think, with a different type of lens. And the fourth area I really think, which is, I'm not sure I'll call it a skill, maybe it's an attitude, but certainly the fourth area I'm looking at is creativity, right? So let's talk about these 4 things, and I'll maybe offer you some views of what we're seeing in the market here in Asia, and certainly what I'm looking to be hiring in the future when I think about data and digital experiences. So the first one, as I said, is model ops. And we all know models are not like conventional software, and there's no concept in DevOps where software decays over time, or you need retraining with new data, or neural networks evolve based on either real or perceived behaviors, right? And certainly what you're going to have to do at some point in time, and boards are getting really antsy about these things, is that they're going to be asking you for transparency into models. They're going to ask you for KPIs or model performance and things like that. And models aren't like software. Some can be operational only for months. Many of them have complex retraining, and quite a few of them actually have unexplainable prediction outcomes. You cannot logically, or you cannot completely explain all the outcomes, right? Obviously, if you took it away, researched it, and etc., you'd be able to, but not always. So I think what's going to happen is that you're going to have a new role, and I don't know what to call it. I call them model ops engineers, model engineers, whatever it is. But this role actually needs to manage the life cycle of the models. So you're talking about treating this like a product, right? So you build it, then you're going to manage it, then you're going to retire it, sunset it, grandfather it, or take it to roadmap iterations and things like that. But you're really going to treat it like how your organization would run a product life cycle, for example. You're going to have to look at people that one of their specialities is actually integrating models into business applications, because these models will not stand alone. And things like you know, digital data, I guess digital decision systems, the stuff that makes the recommendations or uses the data and pushes it out to digital application front ends and things like that. You're going to need someone that understands how to catalog models. So, you know, in the old days, you used to call them service catalogs, but now think about model catalogs. And then now think about, if you now have a catalog, you're going to have delineated audit trails, for example, and you're going to have a way to actually maintain visibility to the interpretations and how and where the model is going to apply. So this is really quite a big field in itself. And I can see actually a real need for any good organization to actually take this quite seriously. I think it used to be like when you had microservices, when you had like 3 or 4 microservices or less than 10, used to be very manageable manually. But then you get until, you know, you get into the 20s, the 30s, and then you get reusable microservices. And then people started calling them microservices swamp. So you're probably going to get into the same stage where people start calling these model swamps, for example. So that, I think, would be the first area where you know, I think skill sets, we see an evolution of skill sets. The second area, as I said, is in data provenance. Data provenance, I think most of you know about, but I think more so now when you adopt like a zero trust posture. Just as, you know, cybersecurity experts now say, you know, anything is not secure until we tell you it's secure. I don't know if we'll get down to that stage with data, but, you know, you may want to, considering how much data is not usable or not useful to you. But really, it's about verifying the origin, the changes to the details supporting the confidence or the validity of your data, and really understanding how to audit and evaluate the quality of what you're doing. And so as a data engineer, I think some of the skills you want to start looking at is how do you do reverse image search, for example. And it's not just image, voice search in Asia is just booming. I don't know if you do this to WhatsApp, but when we use WhatsApp, we don't text. We actually talk into it as if we were having a phone call, and we record our messages. So voice analytics here is absolutely crazy. So you're not only having to do reverse image search, you probably have to do reverse voice search at some point in time, if you could actually probably do that. Locate and things like location, geolocation, when was it taken, when was it done, etc., etc. You know, and you're going to have to do this at quite a large scale, because you're talking, I don't know how much data you use, but say 1 million rows, 1 billion rows. So you're not going to manually examine this, but you're going to have to find ways to do this rather cost effectively. And these really take good, hard technical skills. You're going to do things like use technology to recognize digital watermarks, for example. So a whole field of technology there. Use blockchain type technologies to hold your images, your voice files, etc., and how to make them tamper-proof. For example, you can use blockchain, open ledger blockchain technologies to authenticate digital content, especially things that are coming off uncertified sites, for example. I think one of the most interesting things is really starting to collaborate or starting to use social media platforms who have verified account programs and you know, a lot more stringent checks for achieving verification. So I think there needs to be a lot of critical thinking around data provenance, because you don't want to overdo it, because then it becomes not effective. But you want to do enough so that you can establish trust around that data that you're about to use. Right. So third skill, as I said, it's in data security. Now, this is really interesting. I think this builds on provenance a little bit. I think at some point in time, all the developers are going to be quasi-experts on security. And I think like security incidents, right? I'm going to say cybersecurity. I think for me, what I'm looking at is not really to prevent. So I look after cybersecurity for HGC, and you know, there's only so much I can do to sort of put walls up, make sure I have, layers of security, and then make sure I'm like, keeping the attackers out. There's a little bit of resignation on my part. It's not a matter, are we going to get attacked? It's a matter of when are we going to get attacked and how heavy is that attack? So I take that posture on security. So to me, I'll take that posture on data as well, which is, let me assume that the data is not trustworthy, and what I need to do is let trusted data through. And so verification and validation is my starting point, not detection and prevention. And I think it's probably a better use of data expertise, or the scarce data expertise that we have in this region, right? So some examples that you want to do is like things like things like place restrictions. You can place restrictions on how many inputs can be provided by a source. For example, you can put together a principle that says, small group accounts, or only a small group of users can account for a certain percentage of the training set. You can put a golden data set. You can build a golden data set. And any retrained model must actually accurately predict that data set. Of the obvious one is, use machine learning to put strong access controls in place. I think there's going to be a breed of model or data engineers that actually know how to do red teaming. So this is not going to be the realm of cybersecurity experts, because it actually needs the model experts and the data engineers to know this. So when I think about red teaming, I think about, you yourself attacking your models and understanding how it can be attacked, when it can be attacked, and then building the defenses against those attacks. And I think that's going to be quite a fascinating area for people in the data field. So lastly, creativity. As I said, I'm not sure this is a skill, but I kind of put it in because I think really when I'm looking at people that I want on my data team to push our data initiatives forward, and to really think about how to apply data to solve problems in my business, I am looking for people, be they modelers, designers, scientists, engineers, data ops type people. I'm looking for people that really can have that creative spin on themselves. And I know it's a little bit intangible, but you're thinking outside the box all the time, and you're really creating some unique value propositions with data. And I find that the people that have those ones that have complementary skills, so they're not just all about data. And so things like, for example, one of the things I encourage all my data people to do is to go back and go get a refresher course on advanced probability and statistics, right? And things like, for example, nonlinear statistics, inferential models. So, the ability to think about how to infer things, and why are things related and why are things not related. These are things that, studying data, or studying the computing side or the programming side of data, it doesn't really help you think about these things. But then, I think what this adds to is then when you start identifying patterns, trends, biases, fallacies, and thinking about where your logical errors could happen, I think that's where you get a real leg up on the others in the field. The other area which we see, in Asia, I think if you're in FSI, the amount of people looking for data expertise is phenomenal, right? I don't think there are enough data people to feed the FSI industry here, really. And there's a big push, especially since the start of COVID, to go down that way. So one of the areas I always look at is in the field of econometrics, right? And this is a field that, obviously use stats and maths and models to help forecast future economic trends. And it's really quite a fascinating field. But I think for anybody that's looking or in the financial sector, or looking to move to financial sector, I think that sort of basic understanding, I don't think you have to be an expert, that basic understanding is really going to help you think and look at your data differently. The third area that I think that really can help your creativity is an area called game theory. Now, I studied that when I was in college, and the thinking around that is really quite, how should I say, brings a different perspective to a lot of the approaches to data today. And so, game theory studies the decision making, where an individual's choice actually affects the others, right, that are trying to make the same decision. So it forces you to not just think about data as binary things, but it forces you to think about the intangibles around that data decision and actually convert them into, I guess, binary twins or digital twins of what it is. So you think about strategic situations, you predict how the other entities are going to behave, and it brings together the elements of strategy, human tendencies or assumptions, that of payoff optimization. It brings together things like, are the outcomes negotiated? Would there be a possibility of negotiated outcomes? And these are really rich dimensions when you think about machine learning, because you can now design interactions between agents and to think about the predictive outcomes for things like, how do I achieve social choice, for example, which is collective decision making? How do I take into account strategic options, which are not always tangible options? Negotiated outcomes, auctions, right? So how do you auction off something? And then actually trade-offs, because today not a lot of people I see build trade-offs in their models. Or if they do, it's very rules-based. It's condition A versus condition B. But trade-offs in game theory are quite a different phenomena. So hopefully I've given you enough today to think about, how wonderful this field of AI, data and security is, and look, all the possibilities that are going to come out as, people charge on with their digital transformation, their digital experiences, and data becomes really key of driving this world forward. So I hope that you've enjoyed what I've had to share with you today. And over back to you, Scott.
Jackie, that was awesome. So much so that we've actually run over time, but I couldn't interrupt you because I was enjoying it too much. So we are eating into our networking break, which is absolutely fine. So unfortunately, we won't have time for any questions right now. But I think it was more important that you got across all that that great information that you were providing there. Now, if anybody does have any questions for Jackie, you can obviously connect with her through the app. And you can also arrange one-to-one meetings with other attendees as well. And I'm sure Jackie would be delighted to share some more insight on that as well. And it was awesome. So thank you, Jackie. Thanks for joining us today.
Sorry I went over. Thank you so much for having me, Scott.
Okay, so as I said, we are eating into the networking break. So but I think it was worth hanging on for, wasn't it? So so off you go. Enjoy your networking break. Make sure you can arrange some one-to-one meetings with other attendees, as I said, and you can also visit our sponsors' virtual booths as well. So enjoy the break. We'll see you back in a while.